So we are in, there we go, geometric. So the formula is right here, and let me just start talking about it here. Here's your formulas. We're going to simply multiply by p and then q to the whatever power that we don't want. So let's talk about what p is. Your probability of success, and q is probability of failure. And so the geometric distribution is interesting. The keywords that I would use for geometric, like how do you define it, is until success. I can't spell success. Until success. So here, just let's do some thought processes. Okay. So let's say that I keep flipping a coin until I get a heads. Okay. So I'm going to keep flipping it, I get a tails, and I get a tails, and I get a heads. There it is. Or I take it and I flip and I get a heads. We're done. If I flip and I get a tails, then I get a heads. We're done. Does it make sense? How about basketball? I'm going to keep throwing it and trying to get it in there until I actually get a 3-point, and then I'm done. Then we're good. So like I'm practicing there. Or I'm going to keep swinging the bat until I finally hit the ball. Wham! All right, now we're done, and I can move on. So until success. What's happening then is that we're going to multiply a whole bunch of failures and then one success, essentially. Okay, so let's just do something that's like 25% probable. Oh, cards. Let's say you're going to keep handing out cards until you get a spades. And I know that this is not really perfect geometric, but let's just go with something similar like that. Let's just say that we got 25% for success, and then my failure would be, what's the opposite? 75%. Yeah. So let's say that I'm going to have, what's the probability of doing like 3 no's and then a yes, right? 3 whatevers and then a spades. Or I know this is not really how the cards work, but I'm just making a point. So I'm going to go failure, 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 and then finally success. So that's, I'm going to scroll a little bit so you can see better. Loop. So that's 3 failures and then finally failures, that would take forever. So what we're going to do is a formula. I'm going to do the 0.75 to the power of 3 and then multiply that by that 25. So I'm saying then again that 3 power is saying 3 failures and 1 success. Once we succeed, we're done. Cool? Okay, so that's how that works. Let's now apply it to these kind of situations. So I have no clue what this is, so I'm just going to let that one go. All right. Assume that the probability that you will make a sale on any given phone call is 15%. So find the probability that you make a sale on the 5th call. So you're working for a company and you're trying to make phone call sales. So you know how that works. It's not 15% anymore, is it? No way. People be hanging up on you or trying to lead you on or something. So that's the success. What would be my failure? Yeah, 85%, exactly. And how did we do that? I said 1 minus the 15 makes the 85. I'm going to get it like a little bit more fine tip here. There we go. Cool. Okay, so make it on the 5th call. So how many failures did I have? 4. 4 failures. So I put a little 4 power up there. And then I had 1 success, which was the 15. And that's how it works. I'm saying I got 4 failures and then 1 success, and there we go. So that's my answer. 7 or 8% basically probability. Pretty straightforward. Is this okay? Okay. It says, what about making your first sale on the 4th call? So if you're selling something on the 4th, how many failures did you have? Exactly. So we have 3 failures, 1 success, calculator, and then we're done. And this is why I'm using the Desmos on the side here, because it's really handy. You could use GeoGebra, of course. I just think that Desmos is more efficient, personally. Or any basic calculator will be fine. Okay. Cool. Now, if there was a way to do this in GeoGebra, I would. Like, it would be pretty easy, but we just don't have that in GeoGebra. Maybe because they think it's so easy. I don't know. But let's keep. Oh, here we go. So making the sale on the first, second, or the third call. So this is like 3 different situations that we can have. We can make our sale on the first, we can make our sale on the second, or we can make our sale on the third, right? So on the first, what would be the probability of making it on the very first call? Like, how many failures would we have? 0 failures. I know this is really silly, but I'm going to put a 0 there, and times my success. What's anything to the 0 power? Do you remember? 1. You got it. 1 times 15 is 15%. I mean, that was easy. Okay. Second, so then it says the second call. So I had 1 failure, and then I had my success. And then finally the third call, 2 failures, and then my success. I'm going to go find those. Any questions on what we're doing so far? This is straightforward, basically. Cool. There we go. Now, they said the word or. And I know it's been a little bit. Actually, if you just took your exam, it's not been that long. Or means what? Add. We're going to add them together. So this plus that plus this, grand total. Here we go. You got it. There we go. So 30, 38%, 39%. I'm gonna like box it in 3 times. Yay. Cool. Sound good? Okay. Any questions? Was that page 1? We only got 2 pages of this. You okay? Okay, good. All right. So they give us a new formula. They say the mean is this. Well, what is that? So let me talk about it. That's a mu. That's a mu. Have we ever seen? We've seen it maybe, but not really talked much about it. This is a mean. It's an average, basically. But it has like a little tail on it, and you pronounce it like mu. It's like a kitty. Anyways, mu. It's equal to 1 over p. And so from our previous example, if I wanted to see the average number of calls to make a sale, I would say 1 over the 15%, and then I would just get that answer. It's like really simple math. So I'm gonna like describe this here. This is from the previous problem. So this would be the average calls to make a sale. Average. Just redo that here. Average calls. Cool. So let's just say that you're man. So like if you make the first sale on the first call, bam, get to go home early today. But on average, it would be about 6 calls a day, maybe 7. That's how it works. It says, according to Master Foods, which I'm guessing just does M&Ms because they're talking about M&Ms. Oh, right there. It's the company that manufactures M&Ms. Okay. 12% are peanut. The peanut M&Ms are brown, yellow, red, blue, orange, green. You randomly select M&Ms from a large bag, and you're looking for a red one. Compute the probability that the first red one is the 5th M&M you get. Okay, so you pull it out and you get a blue, and you get a blue, and then you get a brown, then you get a yellow, then you got a red, right? Isn't that how that works? 4, then 1, right? So 4 failures, and then 1 success. I'm gonna put failure, success. So I'm gonna actually write fail and success. So what's the probability of success? What's the probability red? 12%, yeah, 12% for the reds right there. There you go. Well, then what would be failure without doing too much math up there? Yeah, exactly, 88. right? Wouldn't 88 be the opposite of the 12, right? 12, 88. 25, 75, right? 90, 10, all that kind of stuff. So yeah, those are opposites one another. Well, let me put that in now. We're done. We're done here. So 88, 4, then our 12. There we go. 0, 7, 1, 9, 6. So 7% probability that you would get a red one on the 5th. Now it says, what's the probability of the first red candy is on the 5th or the 6th? And or means what again? So I'm going to basically take my 5th, and I'm going to make a 6, and I'm going to add them. So, okay. So my 88, how many failures would I have for the 6th? 5 failures, 1 success, and then I'm going to take these two numbers and add them together. Okay, so there's those. I'm going to put like a big old plus sign here. Is that weird? Is that how you do your math? Chad, you're crazy. Yeah, I know. 96063327. There we go. Cool. Triple box it. Okay. All right. So far, so good. Straightforward. We're good here. Trying to keep it interesting. If every student in a large statistics class, okay, that's right. Yeah, this is like, yeah, I'm sorry. Where did everyone go? Right? We're the dedicated few, though. It's okay. They're probably watching my videos. Print saying something. It's okay. It's okay. You're here in spirit. Okay, we like you too. Anyways, large statistics class at random until they get a red candy. On average, how many would you have to go and grab? We just did something like this, right? There's a formula for it. It's my average is 1 over the p, 1 over the 12. Calculator, and we're done. 8 candies. So on average, you'd have to get about 8 candies on average to get to a red one. I have none. Nope, not today. I had pizza earlier, though. That's about all I got. If you take a weighted coin, whoa. What's a weighted coin? It's what? A non-fair, yes. Yes, you're right. Yeah, I always think of it kind of like a bent coin. Or maybe it's like a coin, but it's got like a little bit of a rounded on one side, so it like wants to not stay on that side. I don't know. Yeah, it's not fair. It's not fair. And it says on average, it takes the first one that you get heads is on the 10th flip. So what's the probability? It's saying that the average is 10, right? But we already have a formula for that. That's 1 over p. So now I need to get my p. How would I do that? Do you know the algebra for this guy? Yep, multiply the p to the other side. And then? You got this, bro. Divide by the 10. Very good. I know. You're telling me that I have to do algebra in a stats class? What? I mean, it's very simple, you know. It's just a little tiny thing here. And so there we go. Ta-da! 1/10. So that's a really bent coin, man. That's really bad. Good? Okay, cool. Awesome. And that was it. Ta-da! So I want to keep going because the Poisson stuff, there's a big section here. And I actually want to do homework on the Poisson section. It's worded weird sometimes, but let's go through the workbook a little bit, and I'm going to pull up some GeoGebra here in a minute. So it's cool to have both of these at once because then you can see what we're talking about. Let's do a small summary. We had binomial like last week or something, and that was true, false, yes, no, success, failure, that kind of thing, right? We had geometric just now, which is until success, and then finally this Poisson one. And again, how do you say it? That's it's like poi, like a boy, poi, and then son, Poisson. So now you have the whatever, talk about it. Needs to be an orange though, because it's on a blue background. There we go. Poisson. Its key distinction is within an interval. Within an interval. And so you're going to see the key word per a lot. And per means all kind of different things. So you could have things per year, happenings per month, pages or errors per page, hurricanes per year. Ooh, shouldn't have mentioned that. I know, right? It's not good right now. Anyways, my father was actually in Tampa when the first one came through, and he was like, "I'm just gonna hang out, man. It'll be great." And I'm like, "Why don't you just come here?" And he's like, "No, I'm good." And he showed me pictures of the water, like up, like to the like the cars were floating. It was crazy. He was like right outside and taking pictures of this. It was nuts. I just don't know what's gonna happen now. Moving on, current events. We're going on. We're moving on. So Poisson, within an interval. So we're doing per this, per that. Now there's this crazy formula here, but like I'm never going to use it because we're going to use GeoGebra for all of this, okay? There is a key thing to though. We have this mu, and they sometimes will use the lambda instead. So this is mu, and this is lambda. But they're both meaning the mean or average. It just depends. I think GeoGebra uses lambda. Either way. All right. At her 3-hour-long soccer practice, Mariah kicks an average of 3 goals in the first hour. So it seems like we got an average of 3 per hour. Okay, let's just say that right now. You want to find the probability that she'll kick 5 goals in the first hour of practice. So now let's go and do the math here, okay? It says, what's the interval of interest? You know, it says 3-hour-long practice, but it then says 1 hour, then it says 5 for 1 hour. I don't know what this means here. Like an hour? An hour of practice? And that's why I want to go to the homework to kind of see what they're wanting to do there. What is the average number of times during the first thing? They just said it. It was 3. So 3. That was easy, I guess. What should the random variable x stand for? Why are we not doing math? That's fine. That's fine. So if you read back up here for a second, I think they talked about x for a whole second. Oh yeah, x. Did they never said it was. Oh, here it is. Here it is. Counting the number of times, x times that an event occurred. So this would be goals. Goals. X is goals. But I'd rather go and do that. I'm going to pull it up. I'm going to pull up the GeoGebra. .org/classic. Cool. And I'm going to go to probability calculator. I want it like over there. Here, let me do this. No, it's gone. It's all gone forever. Okay, let's try this again. But okay, let's start over. There we go. Yay! That's so much better. Okay, so we're going to go to Poisson, which is way down here. Poisson. Again, if you see that hypergeometric, that is not the same as regular geometric. Don't be fooled. It's not the same, okay? The only ones we're using are binomial and Poisson, okay? So anyways, we got this amount here, and then we're just going to put in whatever we want. So it said the average was 3, so I put a 3 in there. Super easy, right? It says, what's the probability of 5 goals in the first hour or whatever? So then I put in a 5, essentially, or you could just look over here, 5. And there it is. That's it. That's done. That's how we're going to find them. Average, and it's done. Very simple. Cool? That's what the goal is. That's what the goal is. I know, how silly of me. Okay, Justin gets 12 texts each hour. Wow. Just wow, right there. But you can see like each, or you can say the word per, right? So 12 is going to be the average that we're going to use. What is the average number of texts that he'll get every 15 minutes? Pause, pause, pause. This is not a GeoGebra problem. Notice that they gave us average, and they say, what's the average? See, isn't that weird? So it's actually just manipulating what we got. I'm doing 12 per hour, and they're saying that this should equal, because it's the average, there it is. It should be blank 3 per 15 minutes. And yes, it is exactly 3. So how do we do that, right? How do we find that? Well, I know we're all probably pretty clever enough to see that, but let's just think about it for a second. If I had 12 and I'm cutting them into quarters, right? There's 4 15-minute sections in the clock. So then, yeah, you get 3. It's very simple. I almost don't want to, it's almost too easy to do. If that's okay, does that make sense? Do I need to draw a picture? Okay, let's do it. One yes means a yes. So we got a clock, and this is 15 minutes. So if we had 12 for the whole thing, but I want to know just for this one here. So 3, 3, 3, and 3. I know, right? It works. That's actually what we will eventually do. Yes, that's actually the more proper version. So it's 12 to over 60, 60, and then times the 15, and that is exactly right. I want to show that actually. You know what? Let's do it right now since you mentioned it, because that is what we're going to do going forward. So this was texts, and I'm saying there's 60 minutes in an hour. I guess text per hour, and then minutes per hour. So far, so good. And then what I want to do is I want to get the amount of texts. Like my answer is going to be blank texts. And so I need to multiply it by something that'll start canceling things. And so I'm going to say here, we got 15 minutes per 1 hour. Okay, so I'm going to start canceling things. I got minutes and minutes. I got per hour. Oh, well, I guess I never had that right there. Hours. So we're ending up with texts. 12 divided by 60 times 15, and we get texts, which would be the 3. That was a pretty bad example, I think. I'm so sorry. But have y'all ever done any chemistry classes? Maybe, maybe not, where you have to like cancel the moles but add the milligrams. And yeah, it's kind of like that. We're gonna go through that here also, but on a small scale. So yeah, let's do more. So a stoplight let an average of 90 cars through every 5 minutes, cycling through multiple green lights. If the average green light lasts 30 seconds, how many cars per 30 seconds? So let's do it. We got 90 cars, and then I've got 5 minutes. And then I'm going to multiply it by, hi there. I'm going to multiply it by the amount of seconds that I have. I know. Y'all are going to not like this. I'm so sorry. We have 60. No. I know. Give me a second. We're going to have 1 minute is 60 seconds. Okay. And then I'm going to multiply this by 30 seconds. And you could totally have done this in your head without me having to do the chemistry. I know you walked into chemistry now all of a sudden. What's up with that? So minutes cancels with minutes, seconds cancels with seconds, and then we just put all the math together, right? What are we left with here is cars. Is this what chemistry looks like? Just tell me. Is it no? I know. Oh, okay. I never took a chemistry class, so I really don't know. I took 4 physics classes. Is that weird? I really like physics. It was really fun. I'm going to use some Desmos to do the simple stuff here. So I got 90 over 5, and then I got 1 over 60, and then I got a 30. All that for just 9 cars. Are there better ways to do this? Yes. Yes. I guess you can say, like the laid out version. But is it making sense? Okay. What I would do if it were me, I would probably convert the 5 minutes into seconds myself. So like that would be 5 times 60 is 300. So 300 seconds, and then I'm going to say divided by this would be the 30. So we got 330 makes 10, right? So then a tenth. I want a tenth of the 99. I mean, and you can do that just in your brain, but that's up to you. All right. Whew. Now we can finally go and use probabilities here. This would be great. And I'm going to show more of the GeoGebra side of things. A 3-year-old child sleeps an average 12 hours a day. Pretty nice for them. What is the probability a 3-year-old sleep in 70 hours in 1 week? So notice that we're converting like days into weeks kind of thing. So I have to understand this as I need an average. What is the probability? Oh, yeah, okay. I need an average per week. So I got 12 hours in 1 day. But then I have 1 day is, 24 hours, right? Yes. Oh, no, we're turning it into weeks. We're turning it into weeks. Right? And aren't they talking about weeks right there? Okay, sorry. Whew, that was weird. So it's not 1 day. It's not 1 day. How many days? There it is. 7 days in 1 week, right? And so if I look at it like this, my days are going to cancel, and I could say 12 times 7. I should probably know that one. 84. Thanks. 84 hours per week. Hours per week, right? So this is going to be my average. That's my average. That's what I'm going to put into GeoGebra here in just a second. That's what I'm going to days into weeks. You multiply by 7 and you're good to go. Cool? Easy enough. I mean, it makes sense on the surface. So here we go, GeoGebra. I'm going to put in my average right here. No, whatever that is, no. I'm going to put my average, not 12, but 84. 84 is my average. And they're saying, what's the probability of 70? I can just simply go down to 70. There it is. And that's it. We're done. The end. We did it. Poisson is amazing. Bum, bum, bum. Thanks. Good. An average of 11 passenger airplanes takes off every 17 minutes at the airport. Is that 11 passengers in an airplane? That's 11 airplanes or 11 passenger airplanes, not cargo. Okay, I'm understanding it. Okay, 11 planes every 17 minutes. Got it. What's the probability of only 8 planes in an hour? So you can see that we need to convert this, right? We got 11 planes in every 17 minutes. So when I'm converting this, I want to make sure that my minutes are going to cancel because we need hours. They need hours. So how many minutes per hours? 60 minutes per 1 hour, right? So that's what I would put there. And then the minutes would cancel, and we're going to see that we get 11 divided by 17 times 60 over 1. I know that's really silly, but look what I did. Is that okay in GeoGebra? Yes. Yes, that'll be acceptable. We're going to continue to do silly things like that going forward because I don't need to keep looking at it. Just put it in, you know? So, and yes, you do not need to divide by 1. I'm just being silly there as well. So they're saying, what's the probability of only 8? Like, they fixed it for me. How nice of them. Automatic. So yeah, only 8. Enter? Do I need enter? Like, isn't it going to be like right there? Am I wrong here? Oh, no. What's wrong? Why is it so not working? Okay, so an average of 11 planes takes off every 17 minutes. Probability of 8 planes take it off during 1 hour. That would be so low anyways. Think about this for a second. Like, okay, if I got 11 planes, okay, cool. But then that's like, for an hour, that's 4 of them things. 44 planes in an hour. And then they're saying, no, only 8. You see what I mean? Makes no sense. And that's why I'm looking at these numbers like, why is it a 0? Because it's a 0. Okay? The average is somewhere over here, like I said, around the 40-something, right? 40 planes an hour. Bounce. Cool? Okay, so that's kind of my thing. I'm like, this is kind of weird, but hey, there we go. We did it. So, I mean, that's not my answer right there. I was just like putting that in GeoGebra. 0. 0%. I don't know what else to say. It's a good answer. It's a great answer. I don't have any answer key today. This looks great. Looks great. Yeah. Okay. Yeah. Here we go. What do I put in this box? You already know it. GeoGebra. Okay. What else do we got? I'm just looking ahead. Okay, we only got 2 more pages left. And then do we get out for the day, Chad? Sure. I know. So let's say how long they take. Well, I mean, maybe you'll want me to do the homework. We'll see. No? Okay, we'll see how far we are, okay? The birds. I gotta say, this is one of these star problems. I've seen this so many times on exams. Birds and trains are all over the place, okay? Birds and trains. So we'll see the trains later. So has a bird feeder, got an average of 18 birds every 2 hours. And so what's the probability of bird feeder being visited by more than 5 birds in a 40-minute time period? Okay. So I got 18 birds, and it says every 2 hours. So let's just like, can we automatically convert this to 120 minutes? Can I just do that? Makes it a little bit easier, right? But then I'm looking for them in a 40-minute time period. I can't spell minute. And it was right in front of me. Leave it to a math teacher. Over one, like, I guess, period. I don't know what you would want to call it, but the idea is that they're saying how many in this period. So I'm just going to put it all in, if you don't mind. Here we go. Into GeoGebra. 18 over the 120 times the 40. So we're talking birds. And it says the probability of more than 5. More than 5. Does that include 5? So then 6, 7, 8, 9, 10. So 6, 7, 8, 9, 10. How about this? I'm just gonna type it down here. So starting with 6 birds, let's do 10 birds, 100 birds, 1,000 birds showing up in a 40-minute time frame. That must be a horror film. Call of the Birds. Well, we got our answer. It's 5543 is my probability of that happening. So again, what we're trying to find again is the average. And once we have the average, we plug it in and we do whatever we want in GeoGebra. Cool? Okay, awesome. patients arrive at the ER average rate of 6 per hour. Find the probability that in a 90-minute period, hold up, we can do this on our own, right? See, isn't that 60 minutes? And then we got 90 minutes. So if we take whatever we had, cut it in half for a 30-minute period, and then say like 3 of them guys. 3 30-minute periods. And so in a way, I'm saying like cut that in half, and we get 3. That's every 30 minutes. So 90 minutes would be 3 times that. 3 times 3 is 9. We can do that in our heads. But if you want me to do it the long way, is that a yes? No. Okay. You're good? Okay, good. And then we don't have to overcomplicate it. And if you want me to do it by hand, or I will mostly for birds, trains, but this one was an easy one. So this is my average. And this is what I'm going to be putting into GeoGebra. So I got an average of 9, okay, per 90-minute period. And they're saying, what's the probability of exactly 7? So I'm going to put in 7 and 7, and we're done, basically. So just there it is. Ta-da! At least 10. At least 10. 10 is the least. So we start at 10, but then what other numbers? 10, and then what else? 11, 12, 13, 14. Okay, cool. So then, yeah, if we do that, then we're saying we start at 10, and we go like 12, 15, 20 patients, 120 patients, 1,200 people show up at the hospital all at once. Ooh! Okay, well, it ends up 40-something%. Like, eventually it just gets silly. It's just like, well, the probability of anything else is just 0, okay? But there we go. Any questions? Very cool. Okay. An insurance company is assessing the risk. I don't want to do it. So, no, I'm just playing. Under the company's policies, if a customer lives in an area greater than 5% chance of 4 or more floods in 10 years, the customer must pay a higher premium. Drew lives in an area where the average floods is 10. Okay, number of floods per 10 years is 1.6. Will he have to pay a higher premium? Now, that's pretty interesting. Okay, so they're saying 4 or more floods in a 10-year period. His average is 1.6. We don't have to convert anything. I think we just toss that number in and start like examining what we do here. So we're going to do 1.6, and they're saying 4 or more, right? 4 or more. So 4 floods, 5 floods, 10 floods, 100 floods, 1,000 floods a year. Oh, I'm sorry, in 10 years. My bad. So what we got from all this, though, was a 0.0788. So he's got a 7% chance, an 8% chance of having 4 or more floods. Yes? But they said if it's greater than 5, then it's not cool anymore. So we need to pay a higher premium. Is that the case? Pay a higher premium, so he's got flood issues? So we'll have to pay the higher premium. Oh, no. That one's not. Sorry. We'll have to pay the higher premium, so it's not these guys, because it's greater than. There it is. Cool. Cool. Okay. Keep cruising. Decide which probability distribution. So remember how we were talking about this. I'm going to do this again. This is true, false, yes, no, cheese or no cheese, success, failure. This is until success. We had just done that a second ago. And then we got within an interval. And normally that's like time-based, but it could be other things. So a students of 16 to 18, A's and B's, 75% cheated? What? I'm looking at you guys. You got that smart, bro. It's okay. They can't see you, okay? They only know you're a male. Okay, woo! So, 10 randomly chosen students with A or B to attend college were asked if they cheated. Of course they're going to say no. What a biased question, right? Which is the probability of exactly 2 that answered no? So, before we keep going, they're really just asking, is this binomial? Is this geometric or Poisson? So, I'm thinking, okay, you know what? I'm not going to tell you what I'm thinking. Y'all tell me what you're thinking. This is discussion time. You like Poisson? Because they're cheating within an interval, within an amount of time? Okay. You like that too? You like binomial? Because you're either cheating or not cheating. I like that right there. That's cool too. Somebody say geometric? You keep on trying it until you cheat? Or you keep cheating until you pass? That's what it is. um, so because it has this 10 here and it's a fixed amount, I don't see any particular time frame. There's also right here, there's a third number. This is indicating that you have like these 2 right here, and then a third number indicates binomial. And I'll show you more so. If you go to the binomial here, notice that we have 2 numbers. See that? So we have a n and we have a p. Do we have an n? Do we have a p? See how that kind of fits the mold, I suppose you can say. The Poisson only has a single number, so that's kind of a write-off for that one. And technically, the geometric is the same because that only has a probability. It doesn't have an amount of people, right? So that's on a technical side, but yeah, on the bigger scale, binomial because you either cheat or don't cheat, essentially. And they never said like within the next 5 years or something. That's when I would probably try some Poisson. So binomial. Let's actually get the answer then. I have 10. Probability is 75. And then they're saying exactly 2, which, well, I have right there. Look at that. They're not asking for that at this point. They're just asking, is it binomial or not? And so we did it. We're cool. But I wanted to keep going. Is that good? Okay, cool. Let's keep going. So on average, see, that's a key word right there. Do we have an average number right here? We have a total number and we have a probability. What does have an average? Poisson has an average, right? That's that little mu thingy. Notice that 20 trains, there it is, train question. Telling you, man, I've seen it on exams. 20 trains pass the house daily within 24 hours. What's the probability of exactly 9 trains in a 10-hour time period? And so, yeah, this is Poisson because it has the word average in there, and you can see like this 10-hour time period. Pass by his house daily, which means like per day, that kind of thing. All right, cool. So then let's do it. I have to say that I have 20 trains in 24 hours, but I'm only wanting it in 10 hours. The hours cancel, leaves behind trains. And again, I'm not doing any math because I want GeoGebra to do it for me. And they say exactly 9. Cool, 9. There you go. And we're done. 1, 2, 8, 4. Sweet. Trains. You'll definitely see trains and birds on exams. The probability that a student passes a written exam for a private pilot's license is this much. Okay, so 75% for pass. What's the probability that the student will fail in the first attempt and then pass on the second attempt? Would you want that person to be your pilot? Did you know you don't know. I failed the driving test twice, the written one. Yeah. How could you have done that? That's what my father's expression was. He was like, I brought you all the way here twice, and you still haven't passed it. I even studied the second time. You're thinking, how do you study for that thing? Oh, it's okay. I'm driving on the same road with you guys. Yeah. Okay, so we got 75% for pass, but they're saying a failure. They're saying one failure and then a pass. So what's my failure rate? 25, like one time, and then my pass rate was 75, right? Now this one is just a Desmos kind of problem. It's just basic calculator. So again, 25 times 75. Normally we'd have a power there, but it's just a 1. So 18, 75, 18, 19% probability. Oh yeah, this was geometric. I should have probably said that. It's geometric because of the probability stuff. And to fail, I finally passed this thing. Put me in the air. Or like the doctor's exams, right? You keep on failing and failing and failing. That means like people die, and then and then finally you pass. Someone lived after the surgery. Woo! I'm sorry. That's just not cool, was it? Do you know your doctor very well? Me neither. Anyways, any questions on this? Okay, cool. Are you suspicious now? So, I want to go real quick. We got look, guys. I can't let you go so early. Not all them people running around out there. That's why we got the door closed. So I want to just real quick look at the homework for the Poisson stuff because honestly, to me, it is a little bit more annoying than other ones. It's one of those classic grr moments. Like you got to say it grr. Okay, I said it for you. So they said nothing. Here we go. Poisson. I know y'all want to leave. Just give me like 5 minutes. Is that cool? Is like 5 minutes cool? You're like, I'm timing you, bro. Okay. Aaron got an average of 19 emails during his 8-hour work day. What's the probability of at most 6 emails in a 2-hour portion of his day? So this is a question we did not have, but it's very similar, isn't it? 19 emails every 8 hours, but I'm only looking at 2 hours. See how the hours are going to cancel, leaves my emails, and then it says at most 6. So what numbers are we talking here? 0 through 6, exactly. 0, can I click and drag? No. Oh, wow. Well, I guess I could just type it down here. So yeah, at most 6, 6 is the most, 0 all the way to 6. Oh, there we go. Let's type it in. 7, 9, 7, 8. Oh, they're gonna hate this. You want to see if it works? Oh, it worked. Whew. See how it says 3 decimals? Have y'all noticed that sometimes they're really picky about that? Ooh, yeah, I know. It's sad, man. It's sad. But look, and theirs is actually different than mine. If I would have rounded it, it would have been an 8, wouldn't it have? But they said a 9. Okay. Whoa. Did you want to do that? GeoGebra. So, birds! Ah, it's one of my favorites. So, we got 14 birds every 2 hours. Actually, that would be 120 minutes because I'm only focused on 20 minutes. See how that kind of formulaic style works, right? So it says, what's the probability of exactly 1 birds? Did you see that? Look at that. Is that good grammar? 2263. Let's see. Will you take it? Will you take it? Ooh, you don't like it because it's this. Look, did you see that? Did you see that? Inconsistent. Okay? It took it last time when it was off by a bazillion, but this time it's like, no. Okay, so yeah, that's happy. I'm gonna give some feedback on this one. Looks broken. I'm sorry, I have to. And yeah, this is going down. Description? I have to do a description? 1 birds? Submit. All right, glad we got it. Yeah, phone calls. What? Look, it's exactly 0. I mean, it will still be an answer. So let's go through it. We got 10 phone calls every 120 minutes, 2 hours, right? And then I'm saying that's 20 minutes that we're concerned about. And so what's the probability of 0? It's up at the top there, 0. Whoa, 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 whoa. That threw me off. You see that? It's not a percentage anymore. I have to read the question. Go figure. Yeah, I know. It says, what is the time interval of interest? Confetti! Wow, I didn't have to do anything for that. This is why we check this thing over, right? Sometimes it's just wacky for no reason. Awesome. Okay, look, we got this one, guys. What do I put in the box? 55! Woo! Man, I'm feeling good. What's my percentage right now? Oh, I'm only 33, dang. And y'all want to get going here in a minute. So I need to start using that instructor cheat button. Yay! Thank you. I'm so happy that I can cheat on these things. You could do that too, right? You got a button like that? You don't? Are y'all okay with putting in that number? Oh, I'm loving this. This is awesome. Oh, we got trains! I told you it's trains and the birds, man. This is what happens around here. So I've got 13 trains every 24 hours, but I'm concerned about an 8-hour time period. They want more than 5 trains. More than 5. So I'm going to start at what? 6. Then I can go all the way to like 10 trains, 20 trains, 100 trains, 1,000 trains. 1,000 trains in an 8-hour period. Not going to happen, but you know, flying trains? Would that be a thing? They're being so picky with me and inconsistent. Ooh, mean. But now y'all are seeing it though, right? Now you're seeing how. Oh my gosh! Move on. Birds! I'm telling you, man. Birds and trains. How much have I said it already? I'm moving on. Confetti! Woo! Oh, get out of my face, toast. It's called a toast, by the way. All right. So State Department of the Transportation, blah 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 blah. An average of this per mile, 11 more potholes. Use Excel. Okay, so I think that this is just like the other ones, but even easier. So we got 7.8, and they're saying 11 or more potholes. And so we're going to do 11 potholes all the way to 1,000 potholes. And I got 1648. Fine. And so you can see it was even easier than the other stuff. I think they said use Excel, which again, that means GeoGebra to us. It makes it way faster. Okay. Other things. Oh, we got hot dogs. I'm just going to cheat on this one though, okay? Wow, thanks, Chad. Yeah, I mean, it's the same thing every. Okay, we got to read a words. We already talked about something like this, though. Remember that insurance company, the floods? It's something similar to that. I am not worried about this. I'm going to keep cheating. Keep cheating. Better to cheat than repeat. Let's keep going, guys. Hey, there's our flood thing. Look at that. We did that one. I'm just looking to see if there's something crazy out there, and there's not. We're done. Are y'all pretty cool with that? Moderately comfortable? Thank you, guys. I'll see y'all later. Y'all have a great day. Thanks for hanging out.